In this video we shall solve one of the exercises in the chapter. The exercise involves implementing the simulator view interface with a text view class that prints the numbers of each type of animal after each step. We shall use the version of the Foxes and Rabbits project that already includes inheritance and provides both a graph view of the population and a grid view. Reviewing the simulator view interface before we start, we can see that it imports java.awt.color and consists of four methods. The first method, setColor, clearly has to do with graphical representation, so we probably won't need to do anything for that, this being a text view we're implementing. The second method determines whether the simulation should continue to run. It receives a field parameter whose state will obviously determine the simulation's viability. We can assume that the other views have had to do that too, so we should look for clues there. The third method looks like it will be the core of what our implementation will do, reporting on the numbers of different animals at each step. We shall need to find out how to count the animals, or find something that does that for us already. Recall that the grid view already displays counts of the different animals below the main view of the field, so we shall likely find some existing code that does what we want. Our starting point will be an empty class text view that imports color and implements the interface. We've copied the raw method headers from the interface. We now have to add a body for each method, and we must return a default value for any non-void methods. At this stage we can simply use the compiler to tell us whether we've missed anything obvious. There is a warning about visibility of the methods. Recall that all methods in an interface are public, whether this is explicit or not, so the interface definition did not bother to specify public. However, once those headers appear in a class, they appear to have only package visibility, which is a lesser visibility than public. It isn't possible for an implementing class to reduce the visibility of the methods it's implementing, so we have to add public explicitly. Now the empty class compiles and we can add an instance to the simulator. We shall replace the grid view for now by commenting it out. The constructor of text view takes no parameters. The program compiles and runs. It obviously does nothing visible with the text view at the moment. So let's add something to show status to print the step and confirm that this is going to be the method we have to do most of the work on. Calling simulate one step makes it clear that the text view is indeed active. Now we need to add some meaningful functionality. We note from the class diagram that both grid view and graph view make use of the field stats class, so let's see what that has to offer. We can use the document view within a browser to do this. Select Tools, Project Documentation. The class comment tells us that this class collects and provides some statistical data on the state of a field. That sounds promising. Browsing the method comments, we can see that the method getPopulationDetails returns a string describing what is in the field. It does this by generating counts for the field passed as a parameter. That will be very useful for the showStatus method of the text view. There's a getPopulationCount method to find the count of an individual species type using the species class as a parameter. Recall that the setColor method of simulator view receives the species classes. However, we probably don't need to use getPopulationCount because we've already seen that getPopulationDetails will do the counting we need. The reset method resets counts. Again, this looks ideal for the reset method in text view. The increment count and count finish methods also look unnecessary for our purposes, given getPopulation details. But the isViable method will enable us to implement isViable properly in text view. Clearly we need a FieldStats field in the TextView class because it looks like this is going to do pretty much all of the hard work. The setColor method is not relevant to a text view, so we shall leave the body blank. The isViable method can now use the FieldStats object. The showStatus method is going to use getPopulation details. Finally, the reset method delegates to the stats object again. We compile, and creation of the simulator gives us our first indication that we seem to be on the right track. The graph views population details match those printed in the terminal window. Stepping on, though, doesn't bring any change in the animal numbers, and this conflicts with what's seen in the graph view. We appear to have missed a step somewhere that isn't obvious from reading the documentation. Let's look at the source of the getPopulation details method. From this we can see that new counts are only generated if the previous ones are not considered to be valid. In the reset method we see where fresh counts are generated. So it appears that we need to call reset immediately before getPopulation details. Now the numbers are changing and keeping in step with the graph view. And we've completed the exercise. We've completed an implementation of the simulator view interface. The new class prints textual reports of the population numbers after each step.